Now, some of this will be just going more into some of the more interesting ones. The TCP/IP protocol suite is the most common one we see now. It was named after two popular protocols from the suite, just TCP and IP. TCP is connection-oriented transport layer protocol, and we saw that at the transport layer. And as you can see, the IP is at the network layer, and that's connectionless because it would be faster that way. And we don't always know from start to finish where we're going to, what path we will take to get there. Just like if you drive to the mall, you have a place you want to go and you run into a traffic jam, you will alter your way to get to the mall. And so does IP. So it is a suite of protocols we use that govern how data travels over a network. We've used many protocols before this, but TCP/IP seems to be the one that will work with a variety of computer types, and I think it's here to stay. When you study TCP/IP, there are port numbers that are mapped to protocols. So people that do firewalls will many times have to, if they want to allow or disallow a port or a certain protocol to come through the firewall, we would need to know the port number. And here's some of the popular ones that are worth knowing. And of course, well-known ports are from 0 to 1023. And FTP, 20 and 21, both ports are used. Simple mail transfer protocol, that's email. Port 25, maybe you've used a product like Cisco Works or HP OpenView, that would use SNMP, simple network management protocol to manage devices, port 161. HTTP, just surfing the internet. And Telnet may not be as common to you, but if you remote into a router, you would use Telnet, or maybe an older Unix system. And where it's coming from, the source port, is usually a high dynamic number, while the destination would generally be one of these well-known port numbers under 1024, like FTP or HTTP or something like that. So TCP and UDP use ports to communicate with upper layer protocols. That's a pretty nice picture. It shows you the things we would do, like the web browsing with Internet Explorer, using an email client, ping activities, secure shell, which is like a replacement to Telnet but more secured. You can also see in this picture how TCP and UDP are separated. With this, you can see like Telnet and simple mail transfer protocol, domain name system, DNS, HTTP, web surfing, POP, usually POP3 for email. These are all needing the extra reliability, which would slow things down, but there would be more verification between the sender and the receiver to make sure there's no errors. TCP tends to be more reliable. UDP-based applications, as you can see listed there, they've got FTP, DNS, I'm just doing a couple of them, simple network management protocol. These have more of, I guess, a need for speed. They don't need quite as much back and forth reliability checks. So with this, they can get away with UDP and therefore it's faster. It can be faster. So more on this. You saw that with several of the protocols were TCP and the others were UDP. And with this, the ones that need to be connection-oriented and need to be more reliable, and they perform a handshake, have error detection, can correct errors, can adjust how much information is sent to the recipient at a time. It's like a window size. This is all TCP-oriented. TCP reminds me sometimes of making a phone call and the ability to say to the person you're talking to, hey, I didn't hear that, especially on a cell phone. Could you say that again? I didn't catch what you just said to me. Well, with that's TCP with the error detection and correction. And it's doing this with data. And UDP, that ability does not exist. It's connectionless. It's still useful, but yet unreliable. There's no back and forth handshake. It's just like, here it is, I hope you got it. Postcard again. And as you can see in the drawing on the right between the client and the server, this is called a TCP three-way handshake. It's basically saying to this client to server, hi, I want to initiate this connection, so here's synchronize. And then the server is going to come back and say synchronize to you and acknowledge your request. And then finally, we say acknowledge to the server. And that completes the connection. This is called the three-way handshake. Now, ARP, another good protocol, very necessary protocol. I showed you that from the command prompt, where you could see the IP address and the actual MAC address mappings. So that's what it does. It maps the IP address to the MAC address. And these days, we're still using 32-bit numbers. And we're thinking, if you take it down to binary, it's 32 bits, okay? And as far as the MAC address, it's 48-bit if you look at it from that perspective. Although the MAC address is generally viewed not in bits, but in hexadecimal. But essentially, I'm going to back out just to show that to you again, because I still have it there. This is your ARP table. IP addresses of other computers, MAC addresses. It is presented in hexadecimal, as you can see. Most of these are dynamically learned. So when my PC needs to talk to one of these guys, .10, .11, .12, it is able to figure out what physical machine it goes to. If I need to talk to .5, which is not in here, it's going to have to send out a broadcast and try to find that system, which is going to create more traffic. So when you think of the data link layer, which was layer 2, it understands MAC addresses. It really doesn't comprehend IP addresses. You have to get to layer 3, which is the network layer, to comprehend that. So many things we do rely on ARP. And if we're able to look at our own ARP table and resolve it from IP to MAC, great. If we are not able to, that's where we end up doing an ARP request, which is basically a broadcast, trying to find out who it belongs to. And whoever that IP belongs to would normally say, it's me, and here's my MAC address. And it would get, the response would come and it would be resolved. ICMP, Internet Control Message Protocol. With this protocol, it is a status and error messaging protocol. It does not move data. When we use commands like ping, or actually even traceRT, we are depending on ICMP. ICMP echo, request, and reply they show with the ping utility. It has been a very useful tool. Unfortunately, ICMP is used by hackers. And, what's presented here, it's allowed through most firewalls. I think that's changing. It kind of depends. I think with ICMP, we would probably allow it more internally. But I think when we start working out on the internet and trying to communicate through, different vendors, through different companies we're trying to get to, if we decided to go and ping www.microsoft.com or CNN.com or whoever it happens to be that you want to try to ping, which is using ICMP, it would just depend on the destination on whether it's actually going to get through. So it's kind of hit and miss. I would say over the years, ICMP is being blocked more than it used to be. So yes, it is allowed through most internal firewalls, but I think we're seeing more of it being restricted, more so outside, but it depends. So yeah, a hacker could send a redirect traffic by sending bogus ICMP messages to a router and, kind of throw off the whole communication through the ICMP. The management information base, that is something we see more with a protocol called Simple Network Management Protocol with management systems like Cisco Works and HP OpenView to monitor the status of routers and switches and servers and things we care about. DNS, Domain Name System, it is a hierarchical system. It does map the name of the computer, host names, to the IP address. We have DNS servers that hold resource records for a zone. It's called the authoritative DNS record for that zone. Call this domain name service. This can be enabled. Of course, it is enabled to a certain point on the PC to at least work with the DNS. Your workstations are generally not DNS servers. Your servers could be running the DNS service, the domain name service. It could be enabled on a variety of devices. Your home router is likely to have some of this built into it, as well as firewalling and so on. But we used to use a host file, and that had to be, you had to have every entry you wanted on every machine, and we kind of outgrew that a long time ago. So these days it is a hierarchical system with DNS, and our DNS server for our work would not have entries for Toshiba.com or HP.com or any of those. They would just have the information for their own, but yet know how to climb the tree, you could say. They know how to work their way up to like the .com or the .edu, and then work your way down to the proper first level, and then, like Microsoft, and then maybe beneath Microsoft, training.microsoft.com. Secure Shell. This was really kind of like Telnet, but meant to be more secure. So I think old timers sometimes still, they'll say the word Telnet, but they actually mean it has secure shell capability. So secure access to remote systems, and you basically use a secure shell tunnel, SSH tunnel. We would use this instead of Telnet and, the R utilities that you see in the Unix, Linux world. Server and client generate their own private public key pairs. We'll hear more of that in the cryptography chapter. Many times they will use a protocol called Diffie-Hellman for the key agreement, which is an asymmetric encryption. It carries out a handshake process, and they have to agree upon the parameters to actually set up this secure connection, the secure shell. So when you think of secure shell again, by the way, it uses port 22. Telnet used port 23. And it's kind of the way we do things now. What's really funny is if you go out there and look for Telnet client, you will actually find that most Telnet clients have secure shell, or even FTP clients will have secure shell capability built into it, like FileZilla or Secure CRT, and they all have like secure shell built into it. So again, secure shell uses public key cryptography, which is an asymmetric cryptography, and secure shell is used in functions like replacing Telnet, replacing FTP, and that's what they're saying in this part of the slide. It says secure shell is typically used to log onto a remote machine, execute commands, that's replacing Telnet, and transferring files. It's kind of like a secure FTP or a secure copy. So replacing what we normally do with traditional FTP. Remember, port 22, TCP port 22. And when you hear them say something like SSH daemon, that's like a process, and you hear that term more in the Linux, Unix world. So you would see this built into modern operating systems like the Mac operating system, Linux, FreeBSD, Solaris, OpenVMS, and so on. Just many different ones would have this. Even the Windows world, it's like almost a given. Secure shell you see in Cisco. Protocols, SNMP, Simple Network Management Protocol. This would be, again, my example of Cisco Works or HP OpenView, where you want to manage devices and you want to know if your server has had an issue, as maybe certain conditions are met, you want to be notified, like the processor utilization's too high for too long, or you're running out of hard disk space, you would like to be notified, or maybe an interface got shut down on your router or your switch, you want to know about it. This is all SNMP, Simple Network Management Protocol. And with that, it's like the master system is looking at the computers and systems of interest, and they're called agents. And they gather status information about the different devices. Again, the switches, the routers, the servers, anything of importance. And as far as this goes, there is a primitive security. We have public and private. Now, public, if we have public access, it's able to read the information on these devices called MIB, Management Information Base Data. It's kind of like a password of sorts. If we know private, then we could read and make changes to that data. Normally, you would not leave these default community strings, they call it, public and private, because that's kind of like an understood default that anyone could exploit and get information with public and possibly make changes with private. Simple mail transfer protocol, think email. Port 25. This is something that would need to be secured, of course. Transmits mail between different mail servers. It's a protocol to send outgoing mail from the email clients. Many security books bring up a security concern where these systems are being used as a mail relay, an email relay. And email can be basically moved from one email server to another email server and passed on. And if it's not properly configured, you could find that your email server is being used to distribute spam, for example. So bad guys, hacker types, might look for systems that are not configured properly and then make use of those systems to distribute their spam. And if that gets done to you, you are now looked at as a system that is sending out spam. They don't want to communicate with you. They blacklist you. And you say, what happened? I didn't do anything. Well, you weren't paying attention, I guess, is the error here, as it wasn't really secured. Packet sniffers. You could think of a product such as Wireshark, used to be called Ethereal. Okay? And with packet sniffers, these are designed to intercept packets on the LAN, your local area network, that is. And you're just essentially looking at the traffic that's being communicated. There's hardware versions of this. You can do wireless. You can use just general software to do this, like the Wireshark I was mentioning. Sniffers can be used for your people to troubleshoot, so they're used in good ways, but they can also be used by hackers to see if you're not encrypting your information, and it could be plain as anything. They could see that. They could actually see that information. And when you run something like Wireshark, which you could freely download and run on your home network just to get proof of concept, you realize anything not encrypted is clear text. You can read it all. You can catch passwords and usernames. Like if you're doing FTP and it's not encrypted in any way, we can actually read all of it. Here are some packet sniffers. Wireshark is the big one. That's the one that it's been around for ages. It used to be called Ethereal. And it works in a variety of environments. Many books on Wireshark. The others are of slight interest. I mean, TCP dump is more raw looking. A WinDump is similar to TCP dump for Windows. There's an OmniPeak. Cain and Abel is known for a lot more than this. Cain and Abel would be a very interesting one to download and play with on your home network and not your work network. They would not appreciate that, and you'd probably get in a lot of trouble. Cain and Abel is known as a hacker tool. Your virus protection will probably think it is as well. It has great power. If you just go to their website and look at it, you can see that, but it can do sniffing as one of its functions. In this chapter, we've looked at the OSI model. We've looked at a variety of protocols. Look at the TCP/IP protocol suite, and you saw a couple of these: ICMP, UDP, ARP, DNS, Secure Shell.